this one right here. So let's start off with this bad boy. And I want you to solve this triangle completely, which, as you said earlier, means I want to know all the sides and all the angles. Now, before anyone gets to be a smarty pants, yes, this is a 90-degree angle right here. Right? It's my right angle. So, find my other sides. I shall call them C and A. And then I want to know the other angles. This is going to be angle A, and this is angle C. And, well, this is going to be B. And I'll call this angle B. This is my ABC triangle. All right, so I want to solve everything in this triangle. Now, you may have noticed my dimensions are a little bit messed up here. What does this say? What does it say, Dylan? Yeah, how many inches? 3.5? Maybe. Maybe not, though. KJ? 3'5", which is how many inches? Braden?
41 inches.
41 inches. Awesome. So yes, the idea, you're correct in the sense that it is inches. So that means inches, right? And then this means foot. So 3'5" means you need to turn it into how many inches, which thankfully Braden has helped us out there, which is 41 inches, because 3 feet is 36 inches plus 5 inches is equal to 41 inches. All right, so now that we have that in inches, we're going to get the other two measurements in inches as well. But we only have one side, so we're kind of stuck, right? We need to do something different. We can't use Pythagorean theorem because we need two sides for Pythagorean theorem. So what are we going to do? Let's start off with the easiest thing possible, right? This angle right here. I think that's the easiest angle in this triangle. Why do I think this is the easiest angle in this triangle? KJ? The other two angles are solved. How does that help me? Exactly. All angles in a triangle must add up to 180. So for me to solve for angle A, to find that angle, all three angles must add up to 180. So what I'm doing then is I'll rearrange my equation to solve for angle A. Angle A is going to be equal to 180 subtracted by the other two angles I know. So I will subtract 90 and I'll subtract 28. So angle A, and that thing there means angle. Angle A is equal to 180 minus 90, which is 90, minus 28. So I'm getting 62 degrees. All right, now I've solved all three angles. I know all three angles. I just need to find the other two sides. Okay, but I can't use Pythagorean theorem. What do I have? What's my other option I have left? It comes back to my story about those dirty hippies again. Yeah? What's that word? Yeah, we have to use SOHCAHTOA. Right? So we're going to use SOHCAHTOA to solve the other two sides. So we need to pick which side we want to solve. All right? So let's pick a side. Who wants to pick? Oh, and help me pick a side here. Which side we're going to do, A or C? Pick one. A. Let's do A. All right, let's do side A. So if we're going to solve side A, we need to use a trig function that involves side A. All right? So we need to label our triangle relative to pick an angle, either this angle here or that one there. Doesn't make a difference to us. Right? So I'm going to go like this, by the way. This is 62 degrees. All right, let's label our triangle relative to, I don't know, 28. Okay, if we're labeling it relative to 28, our longest side is here. This is our hypotenuse. I'll do my arrow. So it's my opposite side, and this will be my adjacent side. So for me to solve this question, to figure out how long side A is, I need to use the angle that I know, the side that I know, and the side that I don't know, that I'm trying to solve for. So which trig function am I going to use? I'm going to use these two sides and this angle. Which trig function uses these two sides? O and A. KJ? Yeah, so let's tan it up. Let's go tanning, right? So I'm going to do tangent of this angle, 28 degrees, is equal to, and I know my opposite side length, it's 41. 41 over, what I don't know is this side length. Like this. And I can solve this. I can replace this tan 28. I can look up on my trig ratio table, or I can take my calculator out and press the tangent button and type in 28, and I'm going to get a number. And that number is going to be, what, KJ? 5313 what? 5. Okay, 5317. Like that. 41 over A. Now, can I solve this? How would I solve? How do I solve that question? Yeah, Sean?
You would, if I remember correctly, you would then add something just underneath the 531 and then like multiply and divide.
Exactly. Yeah. So I can use my different methods, right? If I use my around the bend method, I could go around like this. Sean is 100% correct. Like that. I could go around the bend. What did I tell you was the first thing you have to do when you go around the bend? How did Caesar, what did he do? Summer? KJ, do you remember? Yeah, divide and conquer, right? So the first step is to divide and then conquer times. Now, alternatively, I told you before that you could do it a different way as well. If you really wanted to, you could go like this. 5317 over 1 is equal to 41 over A. And the alternative method was the kind of the baguette method, where I go like this. I take the two numbers that are diagonal of each other, I multiply them and divide by whatever's left over. I would divide by this. So 41 times 1 is just going to be 41. Divided by this, and that'll give you your value. Right? So we're going to get a value for A. A is equal to what? Yes? 71.1? Good. And now we figured out one side. And does it make sense that this is that large? Does it make sense, 71.1 compared to 41? It does, right? Especially considering this angle is a larger angle, this one's a smaller one, so that side should be larger. And then we know that the longest side should be some number greater than 71.1, right? So you have, for the longest side, you have two options. You could continue doing what we're doing here, or you could do Pythagorean theorem. So we could solve for the longest side. Instead of doing O over A, we could do the same thing, this angle, with that side over that side, or this side and this side. Which trig function uses O and H? Summer? What trig function uses O and H? Yes, great. So we could do the same thing for that side. If we want to solve for side C, we could do a sine function of 28 degrees is equal to the opposite side, which we've already said is 41, divided by, we don't know, the letter C is what we've been using. And we do the same thing. We can replace sine 28 with a value, which KJ is doing right now. Because he's got his trig ratio table out in front of him? Or does anyone know what the sine value is of 28 degrees?
I'm not knowing.
0.469? All right, 0.469 equals 41 over C. And again, you can make this over 1. And if you're going to do around the bend, you can do that, or you can do my cross multiply divide, right? So 41 times 1, divide by this. Divide by that. And you're going to get a value. Let's see, equals some number that's larger than 71.1. Someone give it a try. You're using invisible ink again?
Yep.
Oh. What'd you get?
No, too big of a number.
What'd you get?
That's just rounding, that's a rounding. That was better.
Oh, because you did Pythagorean theorem?
Yeah.
Okay, that works too. Let's see what number we're going to get on ours. It's probably going to be the same. What number did you get? 87.4?
Mm-hmm.
It's a little off from yours though, right? Because you got 82.
No, I got 81.87.
Yeah, so round it up to 82. Right? So you put 41 divided by 0.469?
Mm-hmm.
Okay.
The first one I got like 7 mil.
Yeah, that ain't going to work. Right? That's not going to help us. What? Okay, so KJ got 82, basically. You got 87. Did anyone else try that?
I got 87 too.
You got 87 as well? Okay. All right. So there's some off. And the reason why it's going to be slightly off, KJ, is because we're rounding off this trig ratio, right? So the decimals there are going to change if we went further, or if we just left this as sine 28. If we went 41, you could try this. Try 41 divided by sine 28 on your calculator and see what you get. That will give us an exact number. That'll be the most precise number. Because then we're not rounding off. (41) divided by sine 28. Sean, did you get a number?
87.3.
Awesome. Is that the 41 divided by sine 28, or is that just 41 divided by 0.469?
41 divided by.
Okay. So 87 is probably going to be the closer value. We'll just leave it there. All right. This you guys should be able to do in your sleep. You should have been able to do this a while ago, I think. Everyone can do this, right? Let's try this, and I'll double check it. Here's your y-axis. Here's your x-axis. Place these points right here on your graph. Okay? Do it now. And not using invisible ink. Using real, actual pencil or blood or ink or whatever you got. Or a donut? You did this one.
I'm still confused of how you get the points.
So that's our x value, right? Mm-hmm. So when I'm putting it on here, so for example, if I'm doing this point there, I do the first number, right? 3. So you have to walk into the building before you can go up or down. So this means it's the side to side. It's the left to right. So plus 3 means over towards the 5 here. That's 3. And then up 4. So this coordinate here is 3, 4. That's this guy right here. Does that make sense? It doesn't. All right, you try this one now. So if you're doing -2, -1, you always start from the 0, 0. Okay? So start here and do this one here. So the first number is -2. So which direction are you going to go? Are you going to go that way? Are you going to go this way? Or are you going to go up? Or are you going to go down?
Down.
So you got to walk into the building before you can go up or down. So the first thing to do is side to side. Okay? So this is you walking into the building. And -2 means you're going to be walking towards, are you going to go towards the -5 or towards the 5?
-5.
Yes, but so you're going to go to -2, 2 blocks over. So there's -2, but then you have to do the other coordinate now. That's the first half,
Okay.
right? So, and then it's -1. So this is the up down. So you're from here, you're either going to go this one or that one. Which one is it?
Down.
Yes. So that is this coordinate. Okay? Not this one. This is like the halfway point to getting there.
Okay.
Does that make sense?
Yeah.
Let's try this one.
Okay.
-5, 2. So you start here, and where do you go?
Here.
Yeah. And then, so that's -5, and then 2. From here, where are you going to go?
Right here.
Yes, that's it. So that is the point, right? That's what this is saying. This says this right here.
Okay.
Okay?
Yeah.
Try that one. What's 4, 2?
Straight there.
Yeah? Yeah, you got the right idea.
That's why.
Yeah?
So, like right here.
Yeah, and then what? So that's 3, right? So 1, 2, 3. You want to go 4.
Right here.
And then what?
Right here.
That's it. You got it. Awesome. I like that. Logan, of course. All right. We're moving on to this thing right here. Your new favorite word of the day. The binomial. Dun, 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 dun. All right. A binomial is kind of like a bicycle. How many wheels does a bicycle have? 4. What bicycle? You're riding one with training wheels, aren't you? 2. All right. And if you had training wheels on your bicycle, you would have 4 wheels on your bicycle. This is true. But hopefully you've moved on since then. All right. Binomial means 2. And then the nomial, it just means kind of like terms. 2 terms. So I'm going to show you an example of one. All right? So it's 2 terms joined by a plus or a minus sign. So for example, it would look like this. That is a binomial. You'll be like, wait a minute, that's just a bracket with a thing in it. It's just, there's one term and there's the second term, right? So these are binomials. I have x and I have -7 or x minus 7. That's my binomial. Our goal today is to learn how to multiply binomials. All right? So before we move on to that, we're going to move on to something that you should have covered in grade 9, but who knows with the COVID madness that we live in this universe as it is. So if we do something that has distributive property, I wish I had a rainbow color here. I can't use a rainbow color, I don't think. Nope. I'll use orange. See if it's going to be too dark or not. No, it's fine. All right, so we're going to use something called the distributive property. Does anyone know what I'm talking about, the distributive property? It's math language. So it's not like you go home and go, I remember the distributive properties today. It doesn't happen. It's kind of like Pythagorean theorem. It's something you don't necessarily remember what that word necessarily means, but if I showed it to you, it might ring some bells. So it looks like this. Basically, we're multiplying a binomial or something inside of a brackets by a number out front. That's all we're doing. Watch. If I go like this. Let's make it a little smaller. All right, so we're going to do the distributive property, which just basically means this number out front multiplies by everything inside the brackets. All right, so like this, we're going to multiply this times that, and also times this. So we are left with 4 times x. What's 4 times x going to be written as? It's easier than you think. It's just 4x. 4 times x is written as 4x. And then 4 times negative 7 is what? 4 multiplied by negative 7. This is how many negative days are in the month of February. Yeah, there you go. Negative 28. Except on leap years, in which case 29. Except on every 100 years, in which case no leap year. Weird, huh? Okay, so we get 4 times x minus 7 is really 4x minus 28. This is called expanding. All right, I expanded this. I multiplied it out. Right? So I have 4x minus 7 is really equal to 4x minus 28. Let's try a couple on your own. I have some down below here. It's the same idea. You're going to take this number here, and you just kind of like, right, multiply it up. Multiply it out for both of them. So this becomes what? 3 times 2x is what, KJ? 6x. Correct. 6x. And then 3 times plus 5 is? Correct. Like that. That's all we're doing. That's what distributive property means, is we're multiplying the number out front by whatever's inside the brackets. All right, try the next couple on your own. I have 2 times n plus 7, and then 5 times, yeah. So we're doing these. All right, try them on your own. See what you get. That's it. Great job, Sean. This is good. 2n plus. And then, but it looks like you added this one.
Oh.
What's 2 times 7?
Oh, sorry.
No problem. How you doing, Carol? I want you to try a couple here. I want you to try these ones here, okay? You said I did on this one? Awesome. Way to go. All right, I see a lot of right answers there. So all we're doing again is we're multiplying by both terms here, like that. So I got 2n plus 14. Because 2 times positive 7 is 14. Anyone have the last one for me? KJ?
15x plus 60.
Awesome. 15x plus 60. All right, so that's just the trick. All we're saying is 5 times whatever's in the brackets here. All right, so it gets a little more complicated though what if the number out front wasn't a number at all? What if it was another letter? Then what do we do? Let's look at an example. So for example, I had x minus 7 out front there. What if I had x times x minus 7. It's the same idea. X times x and x times minus 7 equals, anyone know what x times x is going to be? Want to take a guess? Wild guess, Summer? Yeah, so x times x is equal to x squared. Right? If I wrote x squared, it's the same thing as x times x. So this just becomes x squared and then x times negative 7. We already did this basically in the one before. A letter times a number is just the letter with the number. So it just is negative 7x. So x times x, x squared, x times negative 7, negative 7x. All right? You try the next bunch. Let's see how we're doing. So 6x. So now the x's get multiplied too. So yes, 6x, but squared, right? And then 2x times 5 is 10, but don't forget the x. Not squared though, because it's only going to be squared if it was multiplied by another x. Okay, so do the numbers first. What's 2 times 3? Good. So that's 2 times 3 is 6, and then x times x is x squared. 2 times 5 is what? Yeah, that's it. So it's 6x squared plus 10x. We didn't see. Yes, so good. 6. And then what's x times x?
X squared.
Yep. So 6x squared plus, because you're going to do 2x times 5x. What's 2x times 5x? Do 2 times 5. Yep.
Does that seem right?
Yes, it does. It's very good. And you just need to have a plus there, and there actually should be an x beside that. Because 2x is being multiplied by 5. So you can't forget the x, right? All right, just to help you along, I'm going to show you as a demonstration the first one here. So 2x times 3x plus 5 is, do the numbers first. 2 times 3, 6. X times x is x squared. So 2x times 3x is 6x squared. And then 2x times 5, well, x has no one to multiply against, so it's just going to hang out there. But 2 times 5 is 10. So it becomes 10x. So that's what the first one looks like. So if I give that to you as a model, hopefully it might help you with the next ones. All right? Good. Good. Awesome. Good job. Let's see here. Hey, you're on it. Way to go, huh? Awesome. Making sense? Just keep track of the letter. This one, technically, it should still be a Z, right? I sometimes throw you off like that because I change the letters up. Because occasionally you'll have different letters, but it's all the same thing. Okay, great job, Charlie. Okay, so we're getting 12n squared plus 4n, because our 4 times 3 and n times n gives us 12n squared. 4n times just 1, so 4n. And you'll see I used a different letter this time. In fact, I used different letters each time. That's the only thing. Some people wrote 36 and they forgot the letter on the end too. So you can't forget it though. We got to keep track of those letters, because if it's not just being multiplied by 3, it's being multiplied by the letter attached to it as well. All right? Okay. So that is multiplying a binomial by a variable or a letter out front and a number out front. So we're getting to the important crispy critter, crispy duck. You ever had duck before? No? It's pretty greasy. It's not my thing. Maybe there's some hunters in the class that have had duck before. Anyone had duck before? No? All right, well. It's tasty, it's just kind of greasy. All right, so if one binomial is fun, obviously 2 binomials is going to be funner. That's correct, right? That's why I teach math.
Funner is not a word.
No, this is math class. Funner is definitely a word. In English class, funner is not a word. But in math class, funner is a word. I take issue with whoever your English teacher is. I make the rules here. I'm the captain now. Okay, so if one binomial is fun, surely 2 binomials is funner. All right, so let's do 2 binomials. So we take our x minus 7. Actually, you know what? I'm going to do x plus 7 because I want to make it a positive number. And then you go x plus 2. Like that. So basically what ends up having to happen here is the same idea of the distributive property, right? In the distributive property, I drew little arrows showing what I'm multiplying. So this term out front here has to get multiplied by both of those 2 terms. And then this term after here also needs to get multiplied by both terms. All right? So there is an easier way to keep track of this instead of drawing arrows all over the place. There's a couple different ways I'm going to show you. Right? And I'm sure you're wondering how that is, which is why I wrote, I'm so glad you've asked. All right? And we actually aren't going to play with algebra tiles. So we're going to use 2 different ways. So we're going to use this thing that's called an array diagram. And I'm also going to show you another method called FOIL. And we'll get to that. Let's start off with the array diagram. Array diagram is just everyone's favorite basic game. Here's what we're going to do. To do an array diagram, you basically make a tic-tac-toe box, like this. Make a tic-tac-toe box. Can you do that? Once you have your tic-tac-toe box, I go like this. I connect all the outside corners like this. So it kind of looks like a waffle that's missing a bite out of it. All right. And what we're going to do is, you notice I put 2 different colors in here? Well, what I'm going to do is I'm going to take the first term here, this x plus 3. And I'm going to put it in these two spots here. X and plus 3 in those two spots there. And in the other two spots, I'm going to put the other thing, x and plus 5. So here's my x plus 3. And here's my x plus 5. Now, you'll notice I keep the sign on there. So whatever sign is in front of the number, I keep it attached to the number, even if it's positive. And I'm going to show you why. When we solve this multiplication, I do this little waffle method, or I call it the array model or array diagram. Sometimes I call it the box method. I call it different things. And what we're doing is inside of these 4 boxes here are multiplications. So this number is being multiplied by that number in this box, or this letter. X times x is what? What's x times x? And remember, KJ? Yeah, x squared. So this is just x squared. And then this one here is x times plus 5. What's x times plus 5? KJ? Yeah, 5x. And likewise, we're going to do 3 times x. What's 3 times x? KJ? Yeah, plus 3x. And then the last one is 3 times 5, which is what? Right. Now, you don't always have to put these little arrows here. I'll never actually do that during my thing. When I do the box method, it would just normally be clean. I would just do it like this, in fact. I would go like this, and I do it super quick, and I just go x plus 5, x plus 3, and then I do my values here. All right? So once we've done that, we take everything in the middle, all this value here, and I'm going to rewrite it like this. X squared plus 5x plus 3x plus 15. Now, I can collect like terms in this, right? X squared, I can only add to other x squares. There's nothing else there. There's no other x squared terms. So I'm not going to add it to anything. It's just going to be all by its lonesome. But I can add these two terms. 5x plus 3x is what? Correct. And then 15 is all by its lonesome as well. So my final answer is this right here. All right, I'll do another example. This one is n plus 1 times n plus 4. Set up my tic-tac-toe box. Now, it doesn't really matter which ones you put. If I put x plus 3 down here, or if I put it up there. It doesn't make a difference. They're just being multiplied by each other. All we have to do is remember that one term goes in the top 2, and the other term goes in the other side 2. And we leave a little corner of the waffle with a bite out of it there. All right? So I'll put my 2 terms in again. So I've got n plus 4, n plus 1. And because I'm such a nice guy, I'm going to highlight it again. Try and make it clear. What I'm doing all right. What goes in the box? What goes in the middle? KJ? Yeah, n squared. Right? Because it's n times n. And what's going to go right here? Help me out. Correct. And what goes in this box right here? Owen, do you know?
1n.
Awesome. See, I knew you were on the ball. And then what's this one here? Anyone want to help me out with this one? KJ? Not 5 though, because you're adding them. We're multiplying. Good. It's tricky sometimes to remember that. That's the trick, is that everything inside that area is being multiplied. Right? So then I can rewrite all that stuff there. So I'm left with n squared plus 4n plus 1n plus 4. And then I can simplify that because I'm going to collect like terms on these two there. So I'm left with n squared plus 5n plus 4. Like that. All right? Yes. Yes. We have 30 minutes left, and I'm trying to figure out how much I left for you guys to do on this one here. I think I have a bunch of questions that I want you to practice on your own. I do. So the rest of the 6 there, I want you to try those right now, and we'll take them up. And I'll write your name on the spot, maybe. Or actually, I'll just write up the questions here, and then you can voluntarily put the question up. How's that sound? Better. How's that? All right, so try the other 6 on your own, and we'll take them up in 10 or 15 minutes. I'm going to see how you're doing. That's good. Okay. 12g squared plus 14g plus 4. Awesome. Okay, here's what I'm gonna I'll do another example with you on the big screen here, okay? All right, so for this first one, if I drew it out, kind of looks like that. And let's say, I think most of you guys did it like this, so let's go like this. 4g plus 2, 3g plus 2. All right, so we multiplied these two. So every single thing in these boxes here, in these 6 boxes, is a multiplication. All right, so 4g times 3g gave me 12g squared. 3g times 2 gave me 6g. 4g times plus 2, so they're being multiplied, is 8g. And then the last one is 2 times 2. So what I'm left with is, if I rewrite it out, and I always, always, always can add these two middle terms together as my last step. So I can collect those like terms. and I'm left with this answer here. All right, I'll do another example with you. I'll do this 5k plus 3k plus 2. Same idea, I'll set up my tic-tac-toe table. $5k plus 1. Now, I recognize that some of you might have done this differently. Maybe you put 5k plus 1 here and 3k plus 2 there. It doesn't make a difference. It won't make a difference at all. Right? 3k times 5k. Who can help me out here? What's that going to be? KJ? Yeah, 15k squared. I'll change my... $15k squared. So it's the number times the number, k times k, gets me 15k squared. This is plus 3k. So I'm just concerned with that part there. And I can add these up here. And that is my final answer. Show me your whole method. Don't just show me the answer. I don't care about just the answer. I want to show you how you got the answer.
Do you have an eraser I can borrow?
I do not have a fancy eraser thing. I'll check the desk over here. I doubt that there is one, though. I do not, Summer. I'm apologizing. You could just cross it out and right beside it, though. All right. So some of you who just like to write just the answers, I don't care about just the answer. I want you to show me how you got the answer, right? I want to see your brain processing it. Right? Right, Dylan?
Sure.
Good. All right, Logan, is this making sense to you at all? Does? Okay.
It's just, you did all last year. So.
That's okay.
It's just like, once we get to probably like the next few units is when I'm going to start.
Where you're just like, okay, that you've never seen before. Got it. I figured as much because I've seen some of your work online and you're usually like pretty quick, like you're on it. So when I'm showing it to you, it looks pretty like simple for you. Did you learn a different method than this before?
No.
The same method? Okay. Did you learn the FOIL method too?
I don't remember, but I think so.
Okay. You done? You finished it too?
Sure.
Where's my boxes? All right, you ready for me to blow your mind one last time before we have a break? Now, I'm going to show you the way I learned it, and I didn't learn it using this box method. I like the box method better, but maybe you don't. Maybe you're going to like this method better that I'm about to show you. All right? It's called FOIL, and I'm going to do a couple different examples using FOIL. So FOIL stands for first, outside, inside, last. All right? And what I mean by that is this. I'm going to rewrite that question there. X plus 4, X plus 2. So FOIL, if I did first, it means the first terms. This term multiplied by that term. Right? So x times x is going to be what? KJ?
X squared.
X squared. All right. So that's my first. And then I do outside. So x times positive 2 is what?
2x.
Plus 2x. And then I'll do my inside. So 4 times x is what? You're on a roll, KJ. Keep going. 4x. And then I'll do last. I got plus 8. And I have to do the exact same thing as before, where I have to kind of consolidate those two terms, or collect those two terms. And I'm left with x squared plus 6x plus 8. Now, so that's the other way of doing it, where you don't have to use my tic-tac-toe box if you don't like my tic-tac-toe box. I'll do the same thing here. First, outside, inside, last. So 2y times 4y is what? 8y squared. And then I do, so 2y times 4y, and so 2y plus times 1 is 2y. My inside is 5 times 4y, so I got 20y. And then I got plus 5. Same idea. Okay, so this is the FOIL method, as opposed to using the box method or the array model I showed you. So in math, there are multiple ways of doing something. And if you want to show me your work, I want to see the steps. I want to see what you did. So at least by showing this middle line, Dylan, so by showing me one step, at least I'm showing you my thought process. Right. Not you. Are you skipping my steps? You're using the box. That's fine. I like the box. All right. Do you guys have any preference? Do you think one makes more sense than the other? Megan's like, they both suck. Both of them. They suck. Right? Owen? Any preference? No? All right. So that's the two different ways of doing it. So that's called FOIL. First, outside, inside, last. That's how I learned it. Now you must learn it the same way. No, you don't have to. All right, last 5 minutes, you guys can count things on the ceiling or work on the last question. And if you need help, I'll come around to see how you're doing. And yeah, then we're going to take a break in 5 minutes. So I'm going to come around if you want help or you want practice and you want me to check it. I'm coming around right now. And for those of you who are online, which is possibly just the one of you,